This is where many new hydroponic growers fail. They focus on nutrients, on light, on pH, and they forget that roots need to breathe. Roots respire just like leaves. They take in oxygen and release carbon dioxide. This respiration is what powers the active transport of nutrients into root cells. Without oxygen, roots can't generate the energy they need to absorb nutrients efficiently. Growth slows. Roots turn brown and slimy. Pathogens like Pythium, which thrive in low-oxygen environments, take hold. The plant wilts, even though it's sitting in water. This is called root rot, and it's one of the most common causes of failure in hydroponics. In soil, oxygen comes from air pockets. Well-drained soil has good soil structure, aggregates of particles with spaces between them. Water drains through, and air fills the gaps. Plant roots grow into these spaces and absorb oxygen directly. In hydroponics, there's no soil structure. The roots are either suspended in water, surrounded by a moist inert medium, or periodically flooded and drained. Oxygen must be actively managed. There are several ways to do this. The most common is aeration. In deep water culture systems, air pumps push air through air stones submerged in a nutrient reservoir. The bubbles increase the surface area of the water exposed to air, allowing oxygen to dissolve into the solution. A well-aerated reservoir can maintain dissolved oxygen levels above 6 milligrams per liter, which is ideal for most plants. In nutrient film technique, or NFT, a thin film of nutrient solution flows over the roots. The roots are partially exposed to air, so they get both water and oxygen. The flow rate is carefully controlled. Too fast, and the roots don't have time to absorb nutrients. Too slow, and oxygen levels drop. Ebb and flow systems flood the root zone with nutrient solution, then drain it away. During the drain cycle, air is pulled into the growing medium, oxygenating the roots. This cycle repeats several times a day. Aeroponic systems spray a fine mist of nutrient solution onto bare roots suspended in air. The roots are almost always exposed to air, with only brief contact with water. This provides the highest oxygen levels of any hydroponic system, but it's also the most technically demanding. Temperature is critical to oxygen management. Cold water holds more dissolved oxygen than warm water. At 15 degrees Celsius, water can hold over 10 milligrams per liter of oxygen. At 25 degrees, it can hold less than 8. This is why most hydroponic systems include chillers or insulation to keep water temperature down, especially in warm climates. Another factor is biofilm. Over time, roots, nutrients, and water create an environment where bacteria and algae can grow. Some of this is beneficial. Some of it consumes oxygen. If biofilm builds up too much, it can coat roots and reduce oxygen availability. This is why system cleanliness matters. Reservoirs should be drained and cleaned regularly. Tubing and pumps should be inspected and flushed. Oxygenation is invisible. You can't see dissolved oxygen. You can measure with a meter, but most small-scale growers don't. So they learn to watch the roots. Healthy roots are white, firm, and smell neutral. Oxygen-starved roots are brown, slimy, and smell like decay. Roots are the plant's lifeline. And in hydroponics, oxygen is the root's lifeline. Ignore it, and no amount of nutrients or light will save your crop.